G'day people, welcome back to the lab. We have a Yamaha RX-V765 here today, otherwise known as a HTR 6270. I bought this off eBay and it does not turn on. And I have a gut feeling someone has been fiddling inside. Let's start up all the test equipment and fix this receiver. We'll quickly take the cover off the Yamaha. If we have a close look at the power supply here, it's an absolute bloody mess. We can see the sides missing out of our standby relay. There's a few components that have been replaced and the leads haven't been cut back properly, so it's at risk of shorting with the side of the chassis here itself. So there's been some dodgy work done on this. So what we'll do is we're going to rip out the whole power supply subsection here, and we might end up having to overhaul that. So we'll push on with that right now. Okay, this is our standby power supply. It's a switch mode power supply, and this board serves two functions. It actually powers up the board management controller chip inside the Yamaha itself, and then it waits for you to hit the power button on the front, and then this relay kicks in, and that sends power to the main transformer, and that's when the whole system fires up. So basically this little switch mode power supply here only pulls 1 or 2 watts. It's a standby power supply, and it just waits for that signal just to turn on, and then everything comes to life basically. It's a bit of a mess. We have the side missing out of our relay here. We have our capacitor that's been bodged here. It looks like it's the incorrect type. They've done some lovely soldering work here. We have our input or filter capacitors here. They are way oversized, they're incorrect, so they had to be torn out and replaced. Lots of bodgy soldering. We've got some char marks here, a few more char marks here. The leads to the halfway rectifier haven't been cut back, but that's been replaced as well. So we're going to have to fix all that up. So, you know, basically this board's a bit of a dog's breakfast. So we're going to have to take it back to a serviceable condition to what it originally was like. And then we're going to have to try and repair the fault from there. Let's start off by replacing these two capacitors first. These two polys, they're incorrect. Flick it over, get our iron nice and hot. We'll just pull our first capacitor out. That's one of our old capacitors, and this is the proper one that's supposed to go in. I'm holding here. We'll clean that up with Mr. Toothbrush and some alcohol. It looks like when it was previously put on, he's caused a whole lot of track damage. Totally screwed it, so we're going to have to fix that as well. And if you have a look here, when the wrong components were originally put in, this pad was overheated and it's actually destroyed it. You can tell because of all the heat and all the crap here. So we're going to have to replace that pad or do some sort of bodgy job just to get that all repaired. We'll put our new capacitors in position. It's amazing how much better they fit when the correct size and rating. We are, lovely. Flip him over. We'll solder these up under the microscope because we've got to do a little bit of track repair. So let's drop a little bit of flux here. Just a tiny dab. This helps the solder flow. And we'll just solder what we can and then we'll have to repair the other one. Get a little bit of heat. Lovely. Cut those off flush. Now what we need to do here is with this lead, we're going to have to bend it backwards and we'll probably have to solder it back here. So I'll just cut that off, flush, about there, a little bit of flux as usual. Perfect. That's the best we can do. We'll now take out this faulty relay and this capacitor. As you can see, the whole side's just blown out or something of that nature. So we'll quickly do that now under the microscope. This is that dodgy capacitor. These are these terrible joints. Suck it all up with a wick. Goodbye. Hello, another damaged track. Surprise, surprise. Bit more fresh wick. Get rid of that excess solder. Pull it out from underneath. Might need to reheat that top joint. There we are. Get rid of that rubbish. Now we'll take out the relay. Give the relay a bit of a wobble from underneath. And that's it. Good side, bad side. We're just going to grind down either side of this damaged track. Clean up that exposed copper. We've just put our capacitor underneath, a little bit of flux. We'll do one side. Cut it back. Bend this over. Cut it off flush. A little bit of flux. We'll see if we can tack it down here. Building our bridge. Lovely. That'll do the job. Bit of alcohol, toothbrush, clean up our new little link. This is our old relay, and this is our new relay. So we'll just pop him in and solder it from the other side. I have to preload my iron with a little bit of solder. Just have to do one leg. There we go. And that will hold the relay in place. Let's quickly do the other three. In the original. Some nice propylene alcohol, toothbrush. Just clean that area up. We're now going to change our little half-wave rectifier here. And what this actually does is it converts the high frequency AC, or alternating current here, into DC, and that direct current gets filtered through these capacitors here. And the circuitry in the amplifier likes working off direct current. AC is to move voltages around the network between power stations and households and things of that nature, and DC is used to power circuits within the actual amplifier itself. And because this has been changed, it's been such a sloppy job, we're going to have to change it back to the original, and we'll do it properly, and we'll see what happens after that. We'll just take our little screw out, get it in an angle, just extract it. We'll just desolder, apply a little bit of heat, suck it all up. Rip out this rectifier, all gone. Check our damage underneath. Plenty of isopropyl alcohol, Mr. Toothbrush, and this is the first time this person hasn't delaminated a track, which is a miracle in itself. Some new heat sinking compound, spray around. You don't need to use heaps of this stuff. Rectifier in, push it back, get it to stick, bring it up a little bit. Marvelous. All screwed in. Now we just got to solder it. A little bit of flux. Help the solder flow. Most importantly, cut them back so they don't short out with the side of the chassis. Just like new. We next change out our high voltage filter capacitor. It is replaced with a newer and higher temperature component. We solder in the new capacitor, getting it the right way around. Then trim off the excess. This newly replaced high voltage capacitor provides a bucket of energy to drive our little switch mode transformer. We finish off our power supply board by fixing the damage. We're just applying a little bit of conformal coating here, which is kind of like paint for our printed circuit board, and we've scraped away all the previous burn damage, and we're just going to give it a light brush. Not the best painting job in the world, but it'll do. Put it on the other side here as well. I had to scrape away a lot of charcoal here. Is we'll just put some more coating down. This is what happens when you use a soldering iron that's too hot. Causes all this charcoal and damage. And a little bit along the edge there. Finally up the back. Dab some around. All done. Next we hit that with a high intensity UV light, because this is UV activated conformal coating. And as soon as we hit it with that UV high intensity light, it'll cook off. We now put in our standby and switch mode power supply board. We resolder our wires to the main power transformer, but they are in a new position just to the right of the old damaged pads. Now we will see if the Yamaha powers up. We plug the cord in and turn on the isolation transformer, and then we turn the Yamaha receiver on. Lovely. It all seems to be working. And even better, no smoke. At the end of the day, I have no idea what the original fault was, but it's working now. The moral of the story is, unless qualified, keep your fiddly fingers out of Yamaha receivers or amplifiers. But if you are interested in repairing other stuff yourself, check out the rest of our channel. Don't forget to share, like and subscribe. Other than that, we will see you next time in the lab.